So the last case study variant we're going to look at will be the ones having to do with RxJava. And as before, there are a couple of different versions of this. One of these versions uses the flat map concurrency idiom, and the other version uses parallel flowables. Otherwise, they're very similar. Let's take a look at the example. So in this case, we're going to use the flat map concurrency idiom. We're going to take our list of URLs, turn it into an observable using the from iterable factory method. We're then going to use the flat map method. And for each URL here, we're going to emit that URL. And I probably want to do from callable, just for the heck of it. You can do that like this. So we're going to say from callable. Notice that this is all going to be running in the common fork join pool. Just for kicks here, just to be able to do apples to apples comparisons, I have a little transformer that's going to subscribe and run all the processing in the common fork join pool. That's not what you get by default with RxJava, but I made it work with the common fork join pool. It works perfectly well to do that. And then what we're going to do is do filter to go ahead and check to see if it's been cached or not. If it has been cached, we ignore it. Otherwise, we call blocking download, which is pretty much exactly the same as before. And then we go ahead and apply flat map with apply filters, which is pretty much exactly the same as before. We'll look at both those calls real quick, though. Note we can use flat map here because RxJava doesn't have that weird quirk that Parallel Streams does, and their flat map works correctly in parallel processing context. Here's download. Blocking download, it just calls call and manage block with the downloaded image. And here's apply filters. You can see here what this does is this, again, uses the observable from iterable method. It uses the RxJava flat map concurrency idiom in order to be able to do the processing. It's very, very similar to before. And let's use from callable here. I think that's a little cleaner. You can see how I was able to use Code Whisperer to do the auto completion and expansion of that. And that also goes ahead and runs the image transformation in a thread from the common fork join pool. All right. So what we then do is after we've done all this concurrent processing, we use reduce with. And you can see that what reduce with does is it's going to stick each of these things into an array list by appending them. So we're going to end up with a list of downloaded and filtered images by appending them each into this list using reduce with. And then blocking subscribe is going to be called. And blocking subscribe is just going to set all the wheels in motion. All the processing gets done concurrently. So that is the variant of the ImageStreamGang case study that uses the flat map concurrency idiom of RxJava. Let's now go ahead and take a look at the second implementation. And this is the one that uses parallel flowables. So same idea, extends ImageStreamGang. We're going to this time, however, use a flowable rather than an observable. And you can see we start by converting the list of URLs into a flowable. And then we're going to use the parallel factory method to convert the flowable into a parallel flowable. And then we're going to associate that with the common fork join pool like we did before. And now we're going to filter out anything that has been downloaded and cached. Anything that has not been downloaded and cached, we're going to download it using blocking download. We're going to apply the filters. We'll see how that works in a second. After all that is done in parallel, we're going to convert this back to a sequential stream. And then we're going to collect the results to a list. And then we're going to use blocking subscribe to set the wheels in motion. Here is apply filters. You can see apply filters basically is the same idea as the previous implementation, except this time we're going to use a parallel flowable instead of the flat map concurrency idiom. So we convert the filters into a flowable of filters, and then in parallel we run all the processing, decorate each image with a filter that will process it, run that process, store the results, and then turn this back into a sequential flow when we're all done. So basically that is how we're going to perform all these operations. And if you take a look at the results, you can see that they're not as efficient as completable futures, and RxJava, for whatever reason, works pretty well for small images for this particular test, and not quite as well for the larger images relative to some of the other models. The other thing to note here, I think, is how much cleaner things are when you use the parallel flowable approach versus the approach that was based on the flat map concurrency idiom. There's just a lot more ceremony with the flat map concurrency idiom than there is when you use the parallel flowable model. But either one works. And you can see also that Project Reactor does very well for the small images here and doesn't do too badly for the bigger images as well. We won't talk about Project Reactor now, but it has a similar flavor to RxJava. So that is the final example of this case study.